The cosmic canvas, our vast universe. Picture this. You're standing on a beach, holding a single grain of sand. Now, imagine that this tiny speck represents our entire planet Earth. That's how incredibly vast space is. There are billions of galaxies out there, each containing billions of stars. The scale of the universe is humbling. Every time we look up at the night sky, we're peering into a vast cosmic ocean. Black holes, nature's ultimate vacuum cleaners. Imagine a cosmic monster so powerful that not even light can escape its grasp. These mysterious objects are formed when massive stars collapse, creating a point in space where gravity is so intense that it warps the very fabric of space-time. As you approach a black hole, time itself begins to slow down. If you were to watch someone fall into a black hole, you'd see them appear to slow down and freeze in time as they approach the event horizon. Scientists estimate that there could be millions of black holes in our galaxy alone. There's a supermassive black hole at the center of the Milky Way called Sagittarius A. That's about 4 million times the mass of our Sun. But here's the most mind-bending fact about black holes. We have no idea what happens inside them. Some scientists speculate that black holes could be gateways to other universes or even time travel portals. While these ideas are still theoretical, they show just how much we still have to learn about these cosmic enigmas. The Milky Way's hidden secrets. Our home galaxy, the Milky Way, is a vast spiral of stars, gas, and dust spanning about 100,000 light-years across. But size isn't the only impressive thing about our galactic home. It's full of secrets that are only now being uncovered. The Milky Way is cannibalizing other galaxies, like the Sagittarius dwarf spheroidal galaxy. Recent studies have shown that the Milky Way isn't the flat disk we once thought it was. Instead, it's warped and twisted, likely due to past collisions with other galaxies. Some of the stars in the Milky Way are nearly as old as the universe itself, dating back almost 13.5 billion years. This means our galaxy has been around for almost the entire history of the universe. It's a reminder that our galaxy, like everything in the universe, is in a constant state of change. Exoplanets, worlds beyond our own. Not too long ago, the idea of planets outside our solar system was purely science fiction. But in the past few decades, we've discovered thousands of these exoplanets, and they're stranger than anything we could have imagined. One of the most exciting discoveries is the sheer number of potentially habitable planets out there. These are worlds that orbit their stars in the Goldilocks zone. Not too hot, not too cold, but just right for liquid water to exist on the surface. Current estimates suggest there could be billions of such planets in our galaxy alone. We've found planets that defy our understanding of how solar systems form, like WASP-12b, which completes an orbit in just 26 hours. Then there are the rogue planets, worlds that don't orbit any star, but instead wander through the galaxy on their own. It's a sobering reminder of the harsh realities of cosmic evolution. The mysterious dark matter and dark energy. Everything we can see, all the stars, planets, galaxies, and gas clouds, makes up only about 5% of the universe. The rest is composed of two mysterious substances, dark matter and dark energy. Dark matter is like an invisible cosmic scaffolding, detectable through its gravitational effects on galaxies and galaxy clusters. Dark energy is a hypothetical form of energy causing the expansion of the universe to accelerate. The nature of dark matter and dark energy remains one of the biggest unsolved mysteries in physics. Are they particles we haven't discovered yet? Are they manifestations of extra dimensions? Or is our understanding of gravity fundamentally flawed? These questions are at the forefront of modern physics, and their answers could revolutionize our understanding of the universe. Time dilation, Einstein's mind-bending theory. Time isn't as constant as you might think. According to Einstein's theory of relativity, time can actually slow down or speed up depending on how fast you're moving or how strong the gravitational field is around you. This phenomenon, known as time dilation, is a very real and measurable effect. Imagine you have a twin. You take a trip in a spaceship traveling at nearly the speed of light while your twin stays on Earth. When you return, you'll find that you've aged less than your twin. The stronger the gravitational field, the slower time passes. It's a mind-bending concept that challenges our everyday understanding of reality and shows just how strange and wonderful our universe truly is. Cosmic sounds, the music of the spheres. Space isn't silent. While sound waves can't travel through the vacuum of space, there are other types of waves that can. Radio waves, for instance, can be converted into sound, allowing us to hear the cosmos. One of the most famous cosmic sounds is the Song of Jupiter. The gas giant's intense magnetic field interacts with the solar wind, producing radio waves that, when converted to sound, resemble eerie whistles and whooshes. Similarly, Saturn's rings produce a complex series of radio emissions that sound like a cosmic orchestra tuning up. Using a technique called asteroseismology, scientists can detect vibrations on the surface of stars. Perhaps the most haunting cosmic sound is the echo of the Big Bang itself, known as cosmic microwave background radiation. Listening to these cosmic sounds reminds us that the universe is not just a visual spectacle, but a grand symphony playing out across the vastness of space and time. The hunt for alien life. Are we alone in the universe? It's one of the biggest questions in science. The search for extraterrestrial life, or SETI, has been ongoing for decades, using radio telescopes to scan the sky for any signs of intelligent signals. Scientists are also searching for signs of microbial life closer to home, in our own solar system. Mars, with its ancient riverbeds and polar ice caps, is a prime candidate. Europa, one of Jupiter's moons, is another promising location. Recent discoveries of exoplanets have exponentially increased the potential locations for alien life. With billions of potentially habitable planets in our galaxy alone, the odds seem to favor the existence of life elsewhere. The discovery of even the simplest forms of alien life would be one of the most significant scientific breakthroughs in human history. Space weather. Storms beyond Earth. Space has its own kind of weather, driven primarily by the sun. The sun constantly bombards the solar system with a stream of charged particles known as the solar wind. Sometimes, the sun unleashes powerful eruptions called coronal mass ejections. These massive bursts of plasma and magnetic field can interact with Earth's magnetosphere, causing geomagnetic storms. These storms can disrupt satellite communications, cause power grid failures, and even pose a radiation risk to astronauts in space. But it's not all bad news. These solar storms also create the aurora, or northern and southern lights. Space weather isn't limited to our solar system either. As we venture further into space, understanding and predicting space weather will become increasingly important. The future of space exploration. As we stand on the brink of a new era in space exploration, the possibilities seem endless. Private companies are making space travel more accessible than ever before, with plans for space tourism and even Mars colonies in the works. One of the most exciting prospects is the James Webb Space Telescope, set to revolutionize our view of the universe. NASA's Artemis program aims to return humans to the moon, this time to stay. The lessons learned from establishing a permanent lunar presence will be crucial for the next big leap, sending humans to Mars. As we push further into space, we're likely to encounter new challenges and make unexpected discoveries. Will we find evidence of alien life? Will we establish colonies on other worlds? The answers to these questions lie in the future of space exploration. The journey into space is, in many ways, a journey of self-discovery for our entire species.